Okay, let's jump right into this explainer. Today, we're going to uncover the mechanisms that actually prevent your Apache Kafka data pipelines from silently duplicating, or even worse, losing your records. We're talking about exactly-once semantics. And honestly, this is an absolutely crucial concept for anyone relying on data accuracy to keep their business running. Think about this for a second. Are your AI models being trained on corrupted data? It's kind of a scary thought, right? But the reality is, if you're just relying on the default Kafka settings without really understanding the implications, your business decisions, your predictive models, your entire analytics dashboard, they might all be built on this hidden foundation of duplicated, totally unreliable data. So let's start with section 1, the silent data killer, also known as at least once delivery. Picture this domino effect in action. Step 1, your producer sends a message, and the broker successfully receives it and says, "Yep, got it." But then, in step 2, a tiny network hiccup drops that acknowledgement before it ever makes it back to the producer. So naturally, step 3 kicks in. The producer assumes the message failed and just retries sending the whole thing again. Bam! Now you've got two identical records sitting right there in your broker. And finally, step 4, your downstream systems process both of those records, completely blind to the fact that one is a total duplicate. Look, if you're a CEO, CTO, or COO, this isn't just some minor technical glitch you can ignore. It is a massive business risk. That single dropped network packet, it translates directly into double-counted revenue, duplicate customer orders, and artificially inflated AI analytics. This is a literal threat to the very dashboards you use to run your company, not to mention the compliance reports you have to hand over to regulators. All right, moving on to section 2. Let's look at how exactly-once actually works under the hood. Now, Kafka doesn't just magically wave a wand and fix this out of the box. It guarantees exactly-once message delivery through 3 distinct mechanisms that all have to work together perfectly. Think of these as your 3 pillars of data truth: Idempotent Producers, transactional APIs, and coordinated consumer groups. If you are missing literally even one of these, your entire pipeline is vulnerable. Let's break down that first pillar. By making a super simple configuration change, just setting enable.idempotence to true, Kafka assigns every single producer a unique producer ID, or PID. And then every single message that gets sent gets its very own sequence number. So if a network hiccup causes a retry and a duplicate arrives, the broker sees that exact sequence number and just silently drops the duplicate. Poof, gone. It completely ensures 0 duplicates and 0 data loss within a single session. But, there is a catch. There are limits to this first pillar. While idempotence is amazing for single message deduplication, it doesn't solve cross-partition writes. It doesn't solve cross-topic consistency. And it certainly won't help with failures that happen right in the middle of a transaction. That is exactly where the real power unlocks with Kafka Transactions. Transactions handle groups of messages that absolutely must succeed or fail together across multiple topics. This prevents partial downstream state corruption from ruining your day. Let's actually look at the code flow to see how these transactions operate. Say you're using Spring Kafka's transactional annotation. First, the system calls init transactions to grab a transactional ID. Then your writes are buffered. They are not actually committed yet. Once everything is totally ready, commit transaction writes an atomic marker across all the involved partitions. And hey, if anything goes wrong during this process, abort transaction just rolls the whole thing back. It's an all or nothing deal. All your messages land in their respective topics, or absolutely none of them do. But hold on, because here is the absolute vital missing piece. You have to use the configuration isolation.level equals read_committed. Your transactions only work if your consumers are actually configured to ignore in-flight uncommitted data. If you forget to set this on the consumer side, they're just going to read uncommitted messages anyway, and your entire exactly-once guarantee just completely collapses at the read side. Plus, each partition needs to be owned by exactly one consumer in the group, and they should only commit offsets after successful processing. Let's bring this all together in section 3, the end-to-end stack. This is basically your cheat sheet. It's a skimmable map of the end-to-end exactly-once stock. Notice how it's built in layers. For schema enforcement, you've got Confluent Schema Registry with Avro. For producer deduplication, you turn on that idempotent producer. For atomic multi-topic writes, you use the transactional.id. And for those safe reads we just talked about, you set consumer group isolation to read_committed. Oh, and if you're doing stream processing,
Kafka Streams actually handles this automatically for you if you use the Exactly-Once_V2 config. Every single layer plays a crucial part.
Okay, so right about now, you're probably wondering, does turning all of this on hurt performance? Well, yes, this is the truthful trade-off. Enabling absolute truth costs roughly a 10 to 30% throughput reduction, depending on your transaction size and partition count. But honestly, for the vast majority of enterprise workloads that are dealing with sensitive financials, global inventory, or critical AI pipelines, paying that performance tax is absolutely worth it for sure. Oh, and a really crucial caveat here that you need to be aware of. This setup doesn't just magically span across your entire architecture automatically. Exactly once is only guaranteed within a single Kafka cluster. If you've got cross-service communications happening, achieving exactly once means you have to employ distributed transaction patterns, like the Saga pattern or the Outbox pattern, right alongside your Kafka transactions. Let's zoom back out for section 4, the business value of truth. Because at the end of the day, intelligent business transformation absolutely requires data infrastructure where you know every single event happened exactly once, can be traced, and can be proven. Getting this right prevents AI bias from sneaking into your demand forecasting and pricing engines. It completely stops those sneaky little 2% dashboard overcounts, which, let's be real, are catastrophic when you apply them to global financials. And it guarantees the regulatory auditability you need to prove your operations are sound.
Finally, Section 5, your migration roadmap. Let's talk action plan.
So how do you actually do this? Here is the game plan. Step 1, go audit your current producers to see which ones are missing enable.idempotence. Step 2, add transactional IDs to any producer that's writing to multiple topics. Step 3, get those consumer configs updated to read_committed. Step 4, test everything thoroughly with Kafka streams using exactly-once_V2. Step 5, validate with Schema Registry that your Avro schemas are backward compatible so you don't break consumers with bad data. And finally, step 6, because exactly once adds a little latency, make sure you monitor consumer lag and set strict alerting thresholds before you ever hit go live. Look, Kafka's exactly once model is literally one of the rare places in distributed systems where you can claim absolute certainty with complete confidence. It transforms your pipelines from, yeah, it's probably right, to this is provably correct. So when you look at your own systems today, I really have to ask you, is your data infrastructure provably correct? Are you making business decisions based on the absolute truth or just an inflated echo of it? It's time to take a hard look at those Kafka configurations and make sure your data is actually telling you the truth.